Hi, I'm David with General Air. When it comes to open root pipe welding, there are two ways that we can put the root pass in: TIG or MIG, but more specifically, modified short circuit. I'm going to weld this 4-inch pipe half with modified short circuit and half with TIG. Then I'm going to cut some root samples out. We're going to take a look at the roots and then we're going to bend them, see which one's better. Now you might be wondering, what is modified short circuit and does it differ from normal or traditional MIG welding? Yes, absolutely. The normal short circuit, we call it CV short circuit or constant voltage, is a bit of a wild process. The wire comes out, it contacts the material, and then it dead shorts. And that's where the name short circuit comes from. Then the wire sits there, there's no arc going on, the wire gets hotter and hotter, and it finally basically pops or explodes and then transfers some of the metal into your puddle. Well, when we've got an open root on our pipe, a lot of times this can break the surface tension of the root pass and push through the pipe, causing a discontinuity or a lack of fusion spot. And if we're trying to get an X-ray quality weld, that's not going to work. So what modified short circuit does is it uses a waveform or a computer control inside of the welder. Now when the wire hits the material, there's an instantaneous high amp discharge coming off the end of the wire. And then the machine slows itself down or rolls the amperage down, and it allows a little droplet of wire to very calmly transition into that root pass. The big benefits of this is as there's not a big disruption of that root pass that's trying to solidify in that open root. So it keeps things nice and calm, which gives you excellent back bead appearance and a lot more control. Let's talk about the TIG setup first. I'm using a 26 series flex head air-cooled torch. The benefit on the 26 series, it has a larger cable that comes into the back of it, and it can handle a lot more arc on time than the normal 17 series. The other thing I like about it, it has this larger handle, so when you're walking the cup, it's easier to manipulate because you just got more leverage to the center of the torch. Now as far as the front end goes, I'm using a jumbo gas lens. For the root, I'm using a number 6 cup, so I can get really tight into the root, a 3/32 2% lanthanated tungsten, one of my favorite tungsten, and then I'm using a stubby back cap just to make sure that that back cap's not getting into the way. Now on the prep side for TIG, I have a 3/32 gap with a knife's edge, so there's not a root land on this pipe. It just goes straight in and it's nice and sharp, so it's easy to break down the walls. I have a 75-degree included angle, so 37.5 cut on one side and of course 37.5 cut on the other side, 75 degrees included. I'm going to be running around 88 to 92 amps. I don't know quite where I'm going to land on the amperage side. It will probably be right at 90 amps. Now on this side I have a full open root all the way from 12 to 6, but on the TIG side I do have one tack in the middle, and that's just so I can weld the bottom side, land onto that tack, reposition, and run the top side. My RMD side, or my modified short circuit side, I'm just going to run one continuous pass the whole way through. Alright, for the modified short circuit setup, I'm using a tapered nozzle here. This is the AccuLock tapered nozzle, as well as a tapered contact tip. This is an 0.45 diameter. It's tapered because it's easier to get into the root of the weld with these smaller diameter nozzles. The wire, I'm using an 0.45 ER70S6. 0.45, quite a bit bigger wire. The modified short circuit works a little bit better with this larger diameter because it's able to talk to the machine. You can use 0.35, and I've done that with great success, but in this instance I do prefer this 0.45. Wire feed speed is going to be 180 inches per minute, and voltage is now going to be controlled by the computer in the machine. There is a small adjustment that you can do with the machine, and it's called the arc length, but for this particular instance I'm just leaving the setup, or the stock setup, and how the computer wants to run, and it works really well. The gas coming out of here is a 90% argon, 10% carbon dioxide, and it's running in DC electrode positive. I went ahead and ground the tacks nice and thin, making sure that the edges are nice and sharp, because with both TIG and modified short circuit, the tie-in in and off the tack can be an area of lack of fusion. So you want to make sure that you have it very, very sharp. We call it a feathered edge. So when the bead either comes onto the tack or you're starting on a tack, that the edge just melts away and you get a great tie-in. All right, here's the 12 o'clock position and where the two processes meet. This is the TIG side, this is the modified short circuit side. The wire side, I went downhill 12 to 6, and the TIG side I went from 6 to 12, so I made progression uphill with TIG and downhill with the MIG side. That's just the way that those processes work really well. Let's take a look at the TIG side. There it is. Got a little bit of silicon islands on the edge, ready for a nice fill pass. This is the bottom side where the two processes meet there. I went ahead and ground their meeting spot. I still have to grind the top side, the tie-in side, at the 12 o'clock position. Now here is the modified short circuit bead. One thing you'll see right off the bat is got a lot more deposition with the modified short circuit. It's a much thicker root pass. So this one's almost ready to go right into a cap, where the TIG side would need probably a fill pass and then a cap. So might be into it for one more pass on the MIG side and two more passes on the TIG side. All right, the welds are all done on this side. Of course, use the modified short circuit for the root, and then I switched the machine over to MIG pulse for the cap. So this one actually only took 2 welds. It is a little bit more convex than the TIG side. Using this, which is called a VWAC gauge, I measured this side to be out at 3/32 of an inch. So I'm almost right there at the most code's maximum of 1/8 of an inch convexity. I'm going to spin the pipe here, and you can see this is where the modified short circuit and pulse met the full TIG out. Now the TIG cap is much lower. This one, using that same gauge, came in right at a 1/16 of an inch. That's really ideal. However, this one took 4 passes to complete. There was a root pass, 2 fills, and a cap. So as far as time goes, the TIG side definitely took a heck of a lot longer. Let's look at the underside. This was a 5G weld, so this is the underside connection. I do have a little mistake here. There's a bit of undercut on this side, and that's my fault, where I just wasn't holding the MIG gun long enough on the sides. The process is basically fast across the middle, hold on the sides, where my TIG side wet in pretty well. So as far as the cap goes, I like my TIG cap pretty well. But again, I'm looking at the inside of my pipe, and it's looking good. So what I'm going to do next is we're going to take straps and samples out of each quadrant of this pipe, so we can take a look at the root in depth. All right, I've got the pipe cut into a bunch of different strips. This is the TIG side and this is the MIG side. So the first thing I want to do is measure out the cap and the root. Let's take a look. All right, here's one of the straps from the MIG side of the pipe. So the first thing I want to do is measure out the cap height. So I'm going to put my VWAC gauge right on the top of the tallest part of the crown, and this one measures just a touch over 3/32. That's great. I'm trying to keep that cap in between a 1/16 and an 1/8. You can also see that it has really good fusion on the toes. Now let's take a look at the root. So I'm going to spin this around and do the same thing, but now with the root surface. Now this is where the modified short circuit really shines. You can get a very, very low cap. What I'm looking for here is between about a 32nd and a 16th. So I'm going to go on that top side, and I am touch over flush. So it's actually about 1/64 of an inch. The benefit to that is that if this is a fluid carrying pipe, that since this the root face is so low, that fluid can just glide right on by and not get slowed down by a big chunky weld there. Here's one of the straps from the TIG side. You can see that the TIG cap is very nice and low, very nice and uniform. One of the great things about TIG is you get a ton of control as you're welding it. We're going to turn it on the side here, and we're going to measure the cap height. Now, I expect this to be pretty low comparatively to the MIG. The MIG, we were at 3/32, and it looks like the TIG is just a touch under 1/16. So that cap is nice and low. You get beautiful toe fusion with the TIG. Now let's look at the root face here. Now the root face has a little bit more convexity than the modified short circuit and the MIG. However, it's still definitely acceptable. I'm shooting for that, 3/32 to 1/16, but it can be as much as an eighth in here, really depending on the codes that you're working to. But I'm going to turn it on the side. All right, this is the highest part of that root face. Put my VWAC gauge on here again. Let's see what we get. So that is just a touch under 1/16 of an inch. So remember that MIG side, we were at a 64th. So you do get a little bit more buildup here on the TIG side just because you're going slower. The MIG root, man, that thing just goes in really, really fast. Both absolutely acceptable when it comes to the face profile and the root profile. I'm not worried about any of those. Next, what we're going to do is we're going to scrub the caps down. We're going to scrub the root surface down with a flap wheel. I'm going to bevel the edges just slightly, and then we're going to put them in a wraparound bender and do a face bend and a root bend. I've got 4 straps of the TIG side. I've got 4 straps of the MIG side. So we're going to do 2 root bends and 2 face bends. So what I've done here is scrub down the cap nice and flush, scrub down the root of the TIG sides and the MIG sides, and then I've beveled the edges so when we bend them there's no sharp points that's going to cause it to crack. And what I'm going to use is a wraparound bender, so it's going to grab the coupon and spin it around. I'm going to have 2 face bends on the TIG side and 2 root bends, and the same with the MIG side, 2 roots and 2 faces. Let's see how it comes out. All right, got all the bend samples done. This row is the MIG samples. We've got 2 caps, 2 roots, and then here are the TIG samples, 2 caps and 2 roots. First up is the worst failure out of the whole group, and that is on this root on the MIG side. So this was the modified short circuit root, and right here you can see a corner crack. Now with most codes, it's okay to ignore a corner crack as long as it's not large. Most codes would say that's about 1/4 of an inch, unless there's presence of slag or some sort of contamination or lack of fusion. But I actually know how this happened because I saw it before I bent it. This weld terminated right there, and there was a little pinhole. Now when you're doing a root weld with the modified short, if you have to stop somewhere, the best practice is to grab your grinder and to grind your stop, because there can be a little bit of a fisheye in there, and then tie into that. I didn't do that there, and that's the result. Not a huge deal, but you can see that's something you need to be aware of when you are starting and stopping with the modified short circuit MIG. Here's the next root sample on the modified short circuit. It's got great root fusion. It's stretched really well. There's no defects. The only thing I can say is there's just a small little dent there in the middle, and that's pretty common with the modified short circuit. Sometimes you'll get a little bit of suck back in the middle there, but nothing really to be concerned about. This one turned out great. Here's the first cap for our MIG side. It looks great. We have great fusion. It bent well. There's no discontinuities or defects on it. The only thing I can say is there's just a little bit of dents in between where I was weaving the gun back and forth. It's just a little tiny area of low fill. It didn't measure anything significant while the piece was straight, but when it got stretched out, it has a little bit of a shadow there. Nothing really that's going to cause you to fail if you're doing a bend test for real. but the way to get rid of that would just be to pause a little bit longer on the sides when you're weaving across for your cap. All right, the second cap strap on the MIG side. And again, you can see those little low-filled spots. Again, that's in between that electrode moving side to side. It's definitely nice and light, but overall, again, we've got no lack of fusion at the toes. The sample stretched really well, and I like the way that turns out. So it'd definitely be a pass if we were doing a weld test or a performance qualification for this process. Here are the caps for the TIG side. I decided to just pull both of them out because there's really nothing to see. That's very common with TIG. It's a very clean process, very high quality. There's really nothing in there that I can spot as a problem or even really anything to talk about. They stretched out, they perform like they should, and they're nice and smooth. Here's the first sample on the TIG root, and it looks great. We've got great fusion at the toes, it's stretched out well. There's really nothing to talk about here. Here's our second root pass on the TIG side, and then there is a discontinuity, and it's where there was a tie-in. So I had a tack here, and coming off of that tack into the main root, I was just going a little bit too fast and didn't add enough filler metal, and that's why we got this little suck back piece. Suck back meaning that the bead, when it was liquidy, it just went whoop, right back in towards the arc, and you've got that little dent. I wouldn't say that's a defect, and it wouldn't disqualify this strap as passing, but it's something notable on the piece and something I can do better for next time. All right, both processes did really well. They both bent up just fine, with the exception of that little corner crack, but the biggest thing to think about is the pros and cons of each of these processes. So on the TIG side, the pros are that you get a beautiful looking cap, it's consistent, you get quality every single time. Cons are it's slow and it takes a high degree of skill to do it correctly. So the pros on the MIG side is that it's fast and there's a low barrier to entry. It's easy to use. You can train a lot more people use this process than the other ones because it's user friendly. The cons, of course, is you got to watch out for some of the fusion related problems that can happen with this because the roots go in so fast. But if you got a good eye out for it, this is a great option for welding pipe. Thank you so much for watching. If you like our content, hit that subscribe button for us. If you want to learn more about General Air, the link for our website is in the description below.